Assalamualaikum everyone. Actually, I got an assignment to code some evolutionary algorithm to minimize this particular function that I have written in front of you people. Okay, to find the values of x1 and x2 such that they minimize this function. Okay, and the range of values is -1024 to 10223. Okay, this is the defined range of this values for x1 and x2. Okay, first of all, let's just go through the flowchart of the, or you can say flowchart diagram of the evolutionary algorithm. Okay, there is a start node, then we do some initialization, random initialization of population, and then here we do some selection. And based on some criteria we have defined here, we proceed to the crossover or we go to the end, that if that particular criteria got met. Okay, and if not, then we go to the crossover and we do crossover, and then we do mutation, and then we go back to the selection function. Okay, the selection step of this whole algorithm. So I'm not gonna really code in front of you people, but I'm gonna explain the code that I have written for this problem. Okay, the problem of minimizing this function. Okay, the first concept that you people need to understand in advance, that I will create a array of population, and this population array is gonna contain an array of chromosomes, and the chromosomes, the number of chromosomes that we want, okay, in population, and that it will contain, the chromosomes will be containing two genes, x1 and x2. Okay, I have defined that as x, and these x will contain some values. Okay, means for x1 may contain a values of arrays such as 0 0 0 1 1 0 1. Okay, note that we are gonna initialize the population with binary number 0 as 1, as we know that in this our population or chromosomes should have binary values, genotype values. They should have genotype values. Okay, that's why. Okay, this is the whole array I will be defining. Okay, and in this way, as we have the boundary of these values, okay, the range of values in which our gene values should lie. So for this, I'm gonna define that the value of chromosome, the number of values of chromosome should be 11. Okay, as we know that 2 power 10 equals to 1024. Okay, and so that we can use 10 bits to represent the values between 1024 till 1024, and to show negative values I'm gonna use one additional bit, that's the 11 bits, to show the sign that if the 11th bit is 0, it means it is positive number, and if the 11th bit is 1, it means it's negative number. Okay, so these are the initial understandings that you require to understand my code. Okay, now let's move to the Matlab. First of all, what you need to define is the function that you want to minimize. You can give it any name. I have given it the name of fitness. Okay, fitness function. I hope you people know how to define a function in Matlab, and then you control S, and you save that function file in your particular defined directory. Here in my directory is C, users, HMOL, documents, Matlab. Okay, here I'm defining this directory. I have defined all of my Matlab functions that have yet coded. Okay, the next thing is, as you can see in the flow chart, that what we do first is we do random initialization of the population. We're gonna do these initialization with while keeping the values of our the chromosome genes within this range. Okay, for which we will be defining the number of bits that we are going to use for this, for number of bits that we are going to initialize. Okay, first, moving towards, I have created this initialization function which will return some population, and it's we are going to give it the number of chromosomes that we want in this population, and the number of genes of each chromosomes, and the values of each genes that we want. And I want its values to be 11 here, and its number of genes to be 2, and I'm gonna define populate initialize only 4 chromosomes. Okay, after that what comes is some selection. Okay, as you can see, a selection step. Okay, and for this I have defined a selection function which is gonna do what is to first of all convert these binary values, okay, binary values of genes of chromosomes into some their decimal equivalents, okay, decimal values, because using those decimal values we can compute their function values. Okay, we can compute the function values. Okay, the function will be passed here, okay, of which in our case is this function that I will pass these values, decimal values to this function, and it will compute using for of that particular chromosome. It will use its 2 genes to compute its function value for that chromosome. Okay, so here what we were in selection, yeah, selection function. Okay, what it's going to do is it's simply going to find the function value for each chromosome, and then it will sort the fitness, or I'm gonna call it fitness value. Okay, it's gonna sort the fitness values in ascending order, means the smallest value of the function, then is the bigger, and so on. And what I need is the smallest 2 out of 4, the smallest 2 function values in this array, and I'm gonna save them, I'm gonna store them as a new generation. Okay, we have done some selection, but I'm not, in this case, in my case, I'm not gonna define any selection criteria here, as my stopping criteria of this function is the number of iteration which I have defined, which I will show you later. Okay, after selection what comes is, okay, here I think I should tell you people how my binary to decimal function is gonna work. I have particular to that, okay, specific to this my problem, I have defined this function. Okay, as we know that in binary to, let me clear all this. Okay, as we know that binary to, how we do binary to decimal conversion, binary to decimal, we multiply. For example, these are my binary values. Okay, in my case, for example, let's take them 4 values, and the last one is indicating the sign. Okay, how I will convert this into decimal value? For this, I'm gonna multiply each of them with increasing power of 2. Okay, 2 power 0, 2 power 1, and 2 power 2. Okay, and I will add them. This will give me the numerical value. Okay, which will be in this case 2, and I will multiply this bit with -1. If it will be 0, it will give me 0 output, and if it will be 1, it will give me -1. I have put the condition that if the result is smaller than 0, then multiply this value with -1, means that my final decimal value is -2. Okay, is that clear? This is what I've used here, that I know that my first 10 values of the gene of chromosome are going to will be used to compute the decimal value. Okay, what I've done, and the 11th value will be used to compute the sign, that if multiplied by -1 it is smaller than 0, then multiply this decimal computed value with -1. Okay, this is how I'm converting this value into this decimal, sorry, binary value into the decimal. Okay, don't worry, you guys can, you guys will see my code, you guys will have access to my code on my website into text. Okay, into text.com. And after this, okay, but where we were doing selection. Okay, here we used binary to decimal, then we computed their fitness for this function. Okay, and later on we selected the 2 parents. Here after that, we know that after selection what comes is crossover. Okay, for crossover what we are gonna do is, in crossover function I'm gonna pass these 2 parents. Okay, and I'm gonna doing crossover of them to produce two more offsprings, and then my new generation will be containing those selected parents and the crossover of them. And the crossover will be like, for example, it will be like, uh, for example, this is my first parent. It have x1 and x2. Let's say A and B, two genes. And this is my second parent. This is my P1 and this is my P2, and it's containing x1 x2 two genes, let's say Z and D. My crossover, my new offsprings will be containing the first gene of parent 1 and the second gene of parent 2. Similarly, my second offspring will be containing the first gene of parent 2 and the second gene of parent 1. This is how I'm doing crossover. And finally, I will be saving these two, I will be storing these two offsprings in my population, in my selection population, in which there were only two parents. And finally, I will again have the population of 4 chromosomes containing two parents and two offsprings. Okay, two children. So this is what happening here. Okay. And after crossover, what comes in mutation. In mutation, I'm gonna pass the gene of each chromosome, each gene of each chromosome one by one to do mutation, and I'm also passing some probability of mutation that I will got so using random function I will got some random number. If that number is smaller than that defined permutation probability of mutation number, then we will alter the bit of at that value. Okay, alter. For example, let me explain this. Okay, for example, the gene of chromosome 1, for the gene 1, okay, gene x1, I'm gonna perform mutation. Its values were, for each value it's gonna do this. Okay, its values were, let's say its values were 1 0 0 1 0 1. It's gonna do what? It's gonna compare if this random number is smaller than this my defined number that I have passed to this function, then alter this bit. Alter this from 1 to 0. If it is 1, convert it to 0. If it is 0, convert it to 1. Okay. If this condition pass, it will convert this 0. For second value, I will again compute a random number and compare this statement. Let's suppose it is false. Then I'm not gonna alter this. For third time, let's say this condition was true, and I will alter this bit into 1. And for the rest of them, let's suppose this condition didn't met, and these values will remain the same. This is now my this is now the mutated, okay, gene of my chromosome. Okay, and the same will be done for the second gene x2, and the same will be, all this same will be done for each chromosome. Okay, this is how I'm doing mutation. And now comes towards the main function where I'm doing all this. Okay, where I'm calling all these functions. For this, first of all, I have defined all the functions that I'm gonna use here. Okay, after that I called the initialization function and passing it the value 4, means I want 4 chromosomes with 2 genes, and each gene should have the 11 values. Okay, the 10 values will be the like the real values and the real number values, and the last one bit for defining the sign of that that value. Okay, then this new population will be then this will be passed to the selection function. After that, these two parents that will be returned by the selection function will be passed to the crossover function. A crossover function will return two offsprings which will be stored in this array. Okay, at position 3 for position for chromosome 3 and 4, and after that I will pass this for each, for you can see for each chromosome, for each gene I'm performing mutation, calling the mutation function. And after this I will after mutation population, I will like reinitialize the new population equals to the after mutation. Okay, so After I'm gonna run this array, okay, 4,000 times, means that there are 4,000 generations. Okay, the number of times the loop will be running will be defining the number of generations. Okay, after that, what I'm gonna do that finally what four chromosomes I will be having in my in this population array. Okay, in this new population array, so it should be new. Okay, what I will do is I will do their binary decimal conversion, then I will find their fitness and I will sort them ascendingly, as I have already I defined that the smaller value, then the bigger one, then the bigger one. What we want is the first value. Okay, for the number of generations, what is the value of function, okay, at 1, the smallest value of function among all these four, and for that what are the values of x1 and x2 for which we have achieved this value. Okay, they are going to be this. Okay, and now let's run this program and you will see that for 1,000 generations the minimum value it have yet achieved with this, for and this value is achieved for x1 value this and x2 this. Okay, let's run it again, maybe we will get some better results, but these are no better. Let's run this again and again. Yeah, this one is better than the previous. I have also achieved very good results through this. I'm not gonna say that this is the the best code for evolutionary algorithm and I'm the expert. Actually, I'm taking this course right now and I'm not the expert of this. I'm not the expert of this subject and this particular field. I'm just sharing what I know. I'm just sharing my knowledge. Okay, you can see that we are getting optimized values. Okay, for x1 and x2 for which we will get the minimized value of this function. Let's increase the number of generation to 5,000 and then we will get the values. We will also check for the decrease number of generations as well. So let's find for 1,000 we are getting this value. I think this is much better. Sorry, for 5,000. For 5,000, yes, this is much better. Okay, like we are getting values of x1 x2 for which the function is minimizing. It's not that much good, but it was just for you people, for the beginners, to have the idea how to code evolutionary algorithm. Okay, let me show my previous results that I once this one I think I could calculate it from the same this code. They were 318 for the number of iterations 50 and the k1 was 32 and the k2 was minus 706. Let's run this for the last time for some small number of generations, let's say 50. Okay, we are getting good values. Okay, let's see where okay guys, this is how this evolutionary algorithm works and I will share the code as well. Thank you.